Section 5.8, inverse trigonometric function integration. By the end of this section, you should be able to integrate function whose antiderivative involve inverse trigonometric function. Use the method of completing the square to integrate a function and review the basic integration rules. Integrals involving inverse trigonometric function. Let's assume that you have y equal sine inverse of x. Now, if you take sine function both sides, you can also write down this equation as sine y equal x. And now if you differentiate both sides with respect to x, take the derivative, differentiate both sides with respect to x. By using the chain rule, this would be cosine of y times dy over dx, and the derivative of x with respect to x is 1. So what is dy over dx? It's a 1 over cosine of y, but we can change this cosine of y in terms of x by using this fact here. We know this relation. Cosine of y is square root of 1 minus sine square of x. That's the one fact, sine square y. And we know sine square y is x squared. So here we can write down square root of 1 minus x squared. Okay, so now using this relation, we can say that because the derivative of sine inverse of x is 1 over square root of 1 minus x squared, integration means it's a antiderivative, so we can write down the antiderivative of 1 over this one is y, which is sine inverse of x. So using that fact, we can say, we can collect this integral rules. Integral involving inverse trigonometric function. Integration of du over square root of a square minus u square is sine inverse u over a. Using this this thing, if you just replace this x by u square, and if you apply the very same rule, whatever I did here, you are going to find out. As you can see here, the integration of 1 over square root of 1 minus x squared is 1 minus x squared is y plus c. My pen is not working here, but this is the idea you can use to find out all this integration. So now we're going to use them as a formula, okay? Integration of 1 over square root of a squared minus u squared is sine inverse u over a plus constant. Integration of 1 over a squared plus u squared is 1 over a tan inverse, arctan means tan inverse u over a plus constant. This formula can be, this theorem can be verified by using very same approach I was explaining here. Okay, so let's look at some examples. We need to find out the integral of dx over square root of 4 minus x squared. We have this formula, we just compare here. A is 2, u is x. So by using this formula, the answer would be sine inverse u means x, so x over 2. Here we can compare this one with this formula. A is you can just what is that? A is square root of 2, and then u is 3x. So just plug the value of a and u and a here, and then this is going to give you the answer. Similarly, to find the integration of this part, you can just compare u is x, a is 3, and u is 2x. So outside there is no 2x, but you can always multiply this top and bottom by 2, and eventually it's going to be in the same form. So by using this 3 formula, you can see here the answer for this one is sine inverse x over 2. By using that formula, the answer for this is, you just have to plug the value of a and u in this corresponding formula. Okay, you see here 2 times 2, and then it's 1/3 secant inverse absolute value of 2x over 3. That's coming from the formula. You see here, secant inverse absolute value of u over a. Now look at this problem, dx over square root of e to the power e2x minus 1. Here, these three formula we discuss here, they are not going to apply directly to solve this type of problem, but you can always use substitution. You can say that, hey, let's say u equal e to the power x, and then, do the substitution du equal e to the power x dx. Since e to the power x is u, so du equal u times dx. So du over u equal dx. So we can change this problem into dx means du over u times, this is u square minus 1 square. Okay, now if you go back and you can look at the third formula, this is exactly the third formula we can use here. So u is e to the power x and a is 1 for this problem. So by using that fact, I'm going to show you the answer. Just replace this e to the power x by u, and then finally by using the formula we can find the answer. So sometime you don't see direct application of this formula, but you can always change the problem into you can use a substitution, and then you might change the problem into one of this form. Okay, sometime while we do that, completing the square might be useful. So if sometime to simplify the problem, we might use completing the square. Completing the square means, if you remember from the college algebra, if you have trinomial like this, you can complete the square. For that, you just have to add b over 2 by looking the b here. Square of that, you have to subtract the very same thing. And first three term, it gives you x plus b over 2 whole square. That's called completing the square. And you have the leftover term from here. By using this trick, we can change this x squared plus bx plus c into completing a square form, and sometime it might be useful for finding the integration. For example, let's say this is the problem you have, x squared minus 4x plus 7. I'm going to complete this square, this here, completing the square. In this case, b is 4, so b over 2 means 4 over 2, which is 2 squared minus 2 squared plus 7, and first three term, it gives us x minus 2 whole square. 7 minus 4 is 3. So I can change this problem into this form. Look at here, x squared minus 4x plus 7 can be also written as x minus 2 whole square plus 3. Now we can use one of those formula we're discussing before. Where is that? This one. We can use one of this formula, this one, and we can find the answer. So sometime completing this square might be useful. So that's the reason the answer is 1 over square root of 3, tan inverse x minus 2 over square root of 3 plus c. Okay, finally, let's review the basic integration rules. You always have to know these rules while you try to find the integration. So these are some basic rules we already discussed in previous sections. Whenever you try to find the integration of scalar times function, you can always keep that constant outside and find the integration of the function. Integration of sum or difference of two functions is actually sum or difference of integration of corresponding function. Integration of du is u plus c. Integration, this is the general power rule. This is we discussed in previous section. This is the integration of exponential function. This is the integration of exponential function with a different base. And these are the integration for trigonometric function. More trigonometric function, and finally these three standard formula we just discussed in this section. So after knowing all these 20 different formula, you should be able to find the integration of the problem we discussed in this course.